today I'm going to be talking to you guys about how you can use math to predict the future, because I know that feeling when you're sitting in math class and you're like, this is so difficult, like why am I learning this? Does this even have any real world application? What's the point of math? And I'm here to tell you that you do use math in your everyday life, and you can use it in the real world, and people do on a daily basis. And one interesting way that people use math in the real world is using it to predict the future. So today we're going to be talking about probability. Probability is the likelihood of any event occurring. So basically you can use math to predict the future, the likelihood of anything occurring. So one classic example that many math textbooks and math teachers, mathematicians use when understanding the foundations of probability is the classic marbles in a bag example. So that is the example we're going to be using today. So in our bag of marbles, we have 2 blue marbles, 4 green marbles, 3 red marbles, and 1 purple marble. So here are all of our marbles. So before we can go any further, we need to talk about independent versus dependent events, independent versus dependent probability. So independent probability is the result of one event does not affect the result of another event. So when one event doesn't affect the result of another event, these 2 events are independent. But dependent probability is the opposite of that. So when the result of one event does affect the result of another event, these 2 events are dependent. The second event is dependent upon the first event. So the 2 problems that we are going to be solving today are one independent and one dependent problems. So for the independent, if we choose a marble, put it back in the bag, then choose another marble, determine the probability that you will randomly pick a blue marble, then determine the probability that you will randomly pick a green marble. So this is independent because you pick the blue marble out of the bag, then you put it back in the bag, then you pick the green marble out of the bag. So that is independent. But on the other hand, this is dependent. If we choose a marble, then another marble without putting the first one back in the bag, what is the probability that the first marble will be green and the second will be red? So this is different than independent because we're picking the green marble out of the bag, then placing it to the side. We're not putting it back in the bag. Then out of the rest of the marbles, there's only 9 marbles left. Then we're picking a red one out of the bag. So first, let's start with the independent. So determine the probability that you will randomly pick a blue marble. Is my face covering? Here, let's move it down here. Okay. So the first step is to set up a fraction. So the numerator, which is the top number, is the number of blue marbles, or the number of desired outcomes, which is 2. And then the denominator is the number of total marbles, or the number of total outcomes, which is 10 because there are 10 marbles total. So the fraction is 2 over 10, or 2/10. Step number 2 is to convert the fraction to a decimal. So in order to be able to visualize it and to see it easier, I went ahead and I multiplied the numerator and the denominator by 10 to get 20 over 100. And then that easily goes to, you can easily convert that to this decimal, 0.20 or 20/100ths. Then step 3 is to convert the decimal to a percentage, and we do that by moving this decimal point 2 places to the right, 1, 2, to get 20%. So there is a 20% chance you will pick a blue marble. Now we need to determine the probability that you will randomly pick a green marble. So same thing as before, the numerator is the number of green marbles, which is 4. The denominator is the number of total marbles, so our fraction is 4/10. Then we need to convert the fraction to a decimal, which on this one I did not do the optional step of multiplying it by 10, but we know that this is 4/10, and then this is just 0.4. Next, we need to convert the decimal to a percentage, which we do that by moving this 2 places to the right. And as we know, there is an infinite number of repeating zeros after this 4, so it is 40%. So there is a 40% chance that you will pick a green marble. Now moving on to the dependent events. What is the probability that the first marble will be green and the second one will be red if you don't put the green one back in the bag? So same first step as before. You need to find the probability of picking a green marble. We already found that, 4/10. Next, we need to find the probability of picking a red marble. Now, make sure you don't put 3/10 because that's wrong. You need to remember that there are only 9 marbles left in the bag because after we picked the green marble, we did not put it back. So the green marble's on the side, so we only have 9 marbles now. So the red marble fraction is 3/9. So this is where it comes, you kind of have to use a bit more math, and you have to use this formula. So this formula is saying the probability of event A or event 1 times the probability of event B or event 2 equals the probability of A then B. So we have 4/10 times 3/9. You just need to multiply the 4 times 3 to get 12, then the 10 times 9 to get 90. Then, since this isn't as easy to do in your head, I just put this in a calculator and I got 0.133 repeating. I moved this 2 places to the right to get 13.3%, or if I just round down, 13%. So there is a 13% chance you will pick a green marble and then a red marble. So remember, you only use the formula when you do not put back the marble or when it's a dependent event. Only use this formula when it's a dependent event. If it's independent, you don't need to do any multiplication. So that is all I have to tell you guys about probability, but I did want to include some other uses of probability in the real world because, let's be honest, how many times are you really going to be picking a marble out of a bag? That is a very good example to understand and learn the foundations of probability, but it's not as practical as some of these other uses of probability, so I just wanted to mention that. So one of the most common uses of probability, in my opinion, is predicting the weather. So weathermen and weatherwomen or meteorologists, they have to use math and probability on a daily basis in order to predict the weather and tell the people the percentage of rain that's going to happen, or snow, or whatever it is. So they have to use math to be able to say, oh, there's a 40% chance of rain today, 50% chance of rain today. So math is a big part of that career. Another example that comes to mind is lottery tickets. So just understanding your likelihood of actually winning a lottery ticket, you have to use math in order to determine that. Another example is sporting event outcomes. So many coaches and players and even fans of sports use math and probability to predict whether or not their team will win this game, or the kicker will kick the field goal. So math is also used a lot in sports, believe it or not. And then finally, this is kind of just the general umbrella term of probability, the likelihood of any event occurring, like whether or not your parents will take you to Disney World or take you to your favorite restaurant. So you can use math to predict that and understand that. And you can use math to predict the future. I hope you guys enjoyed this presentation and maybe enjoy math class a little bit more now. I hope you guys have a good rest of your day.